Hi, in this video we want to solve third problem of Stanford Math Tournament 2019 algebraic problem, two equation, two variable, but a little different because we have fourth power x plus y equal to 2, x to the power of 4 plus y to the power of 4 equal to 1234. X and y are real numbers and we want to find x, y. This video has three parts. The first part, quadratic function, sum and product of the roots, quadratic formula. The second part, Newton's sum, and third part, solve the problems. You can use the time codes in my description. If you know quadratic function, you can pass and go straight forward to Newton's sum. If you know also that, you can go straight forward to part 3. So that cause this video is good for a student that doesn't know anything, quadratic function, Newton's sum or what, and also is useful for a talented student and a professional student who knows quadratic is what, Newton's sum what, and he or she wants to solve the problem. Okay, so let's start. Quadratic function, it's what when we have ax squared plus bx plus c equal to 0 and we want to find x. The formula is what? B plus negative b plus minus root b squared minus 4ac over 2a. So we have two roots. Alpha, for example, they say the first root is negative b plus b squared minus 4ac all over 2a, and the next root is beta, negative b minus b squared minus 4ac all over what? All over 2a. So here we can find something. So let me tell you, for example, an example of this. If we have x squared plus, for example, we can say 6x plus 8 equal to 0. So one way is you say, okay, x plus 2, x plus 4, you can factorize is 0, and it's exactly this. So one answer is negative 2, negative 4, but always it's not as easy as this. Sometimes the roots are real numbers, it has the square root of something. So but I told you this problem that show you can solve this quadratic formula, use this quadratic formula in any case. So let's see here. X is negative b negative 6 plus minus what? Root b squared 6 squared 36 minus 4ac, which is minus 4. A is 1 here. The coefficient of x squared, b is 6, c is 8. So we can say b squared minus 4ac, which will be 4ac 32. 4 times this, over what? Over 2a. So it will be negative 6 plus minus root 4 over 2. Root 4 equal to 2, negative 6 plus minus 2 over 2. So one case is negative 6 plus 2, which is negative 4 over 2, which will be negative 2, and negative 6 minus 2, negative 8 over 2, negative 4. Exactly these two roots, Solution number 1, solution number 2. Okay, now that you've learned these things are what, we want to focus on product of the roots, sum of the roots. So let me write rest with black. If we consider alpha plus beta, we should add these two roots. So this plus minus, it will be cancelled. So we have negative, and the denominators are equal. So if I write, it will be what? So let's write. It will be negative b plus root b squared minus 4ac all over 2a plus negative b minus b squared minus 4ac over 2a. The denominators are equal, so you can cancel negative, positive, negative b, negative 2b over 2a, negative b over a. That's so much important and you should memorize. Sum of the roots equal negative b over a. The first thing we've reached. Now we want to find product of roots. Alpha times beta, it's negative b plus b squared minus 4ac over 2a times negative b minus b squared minus 4ac over 2a again. And now if we want to calculate this, we use the formula, the identity, that z minus w times z plus w equal to z squared minus w squared. It is exactly this. Negative, if we factor from denominator, it will be 4a squared times, look, negative b is z, and w is this part. So we can say it is equal to what? Negative b squared minus root b squared minus 4ac squared. And if we calculate that, it will be 1 over 4a squared b squared minus square root will be cancelled because we raised to the power of 2 b squared minus 4ac, and it will be what? B squared will be cancelled, plus 4ac. So it will be negative will be plus 4ac over 4a squared. We cancel 4a with 1a. It will be c over a. Again, another important formulas that you should memorize. A alpha beta product of roots equals c over a. So here, let's summarize all things. We've reached ax squared plus bx plus c equal to 0. Roots alpha and beta equals negative b plus minus root b squared minus 4ac over 2a. Alpha plus beta equal to negative b over a. Alpha times beta equals c over a. Now the last thing I want to say, sometimes in a problem they tell you that, for example, alpha, some of the roots are, for example, let's write at first with variables s, and alpha beta equal p product, and there are roots of what equation? We can easily say, if you write x squared minus x plus p equal to 0, these alpha beta are roots of that. Why? Let me tell you at first with one example. Suppose alpha plus beta is 5 and alpha beta equal to 6. So here you say x squared, s is what? S is here, p is this. Minus what? Minus 5x plus 6 equal to 0. And also you can factor, it is x minus 1, x, let's check, x minus 1, and oh, you can't factorize, but we can find the roots. I wanted to just tell you an example that you can easily work. Let me change these numbers. For example, alpha plus beta equal to 6, this one. And then it will be what? Minus 6x plus 5. So if you factor, it will be x minus 1, x minus 5 equals 0, and x will be 1 and 5, and you can replace it's correct. In the previous case, it would be some square root of something. So I just wanted to tell you an example. Why it is correct? Because as we said, sum of the roots is what? Negative b over a. Negative b here is what? Negative s over a is 1. It's correct. And product of roots is c over a. Here is p over 1. It's correct. So this idea is useful. Also memorize this if you have something like this, that x squared, for example, it says sum of the roots equal something s, and product of root equal p. These two roots are roots of what equation? You can consider, for example, one equation is this that you can consider. Okay, so I said all the things we need for the problem about quadratic function. Let's solve or work on the next part. The next part is Newton's sum. I want to use that for quadratic function. Also, you can general, because in this video we want only for x squared. You can use it for polynomials with greater degrees. Okay, so Newton's sum, it's what? It's so much useful, especially recently in Stanford I saw that. So you can use this related to a little Vieta's formula. It is what? For example, suppose we have ax squared plus bx plus c equal to 0. So sometimes, for example, roots are alpha beta. Sometimes the problem says find alpha plus beta. I told you the formula in previous part. Sometimes they say you find alpha squared plus beta squared. So because you can find alpha times beta, you can use this. Sometimes they say you find alpha cubed plus beta cubed. A little harder. Alpha to the 4 plus beta to the 4. A little harder, and so on. I tell you only until alpha 4 plus beta 4, and the idea you can generalize. Also, you can generalize it for greater degrees. Here we only consider quadratic function degree 2. For degree 3, 4, all of them you can use. And so I call this one S1, the degrees alpha 1, beta 1, S2, S3, S4. Also, I can also say S0 is alpha to the power of 0 plus beta to the power of 0 is 2. So here I want to find alpha plus beta. For what equation? Let me tell you. I can tell you for this one, or I can tell you for an example. I tell you at first a general case. So we say what? We say, I think for checking one example at first it's better. Suppose it is 5x squared, or let me tell you for example, x squared minus x plus 3 equal to 0. So S0 is what? Is so much easy, is 2. S1 is what? We had a formula from previous part. Alpha plus beta is negative b over a. So S1 is what? Alpha plus beta. Negative b over a is negative b 1 over 1, which is 1. Now I want to find s squared. So let me tell you how you can find. It has also easy way. You can say this squared minus 2 alpha beta, but I want to tell you a way that you can generalize for any other case. So here I say, okay, alpha beta are roots of this equation. So alpha squared minus alpha plus 3 equal to 0. Beta squared minus beta plus 3 equal to 0. If I add these two things, I will have what? Alpha squared plus beta squared, the first one, minus alpha plus beta, and let me move it to this part, or let me write it like this. Okay, so then plus 3 times 2 equal to 0 if we add. Alpha, it is what? S2, it is what? S1. We said S0, 2 is S0. So here we found what? Let's pay attention. Our main equation was this x squared minus x plus 3 equal to 0. I found S2 minus S1 plus 3S0 equal to 0. I want to prove that you can increase indices by 1. S3 minus S2 plus 3S0 equal to 0. And then S4, this one also you should increase this index. And then next one, S4 minus S3 plus 3S2 equal to 0, and so on. I want to prove this. How? Similarly, for example, I proved this one, S2. I want to prove S3. So again, let me write this part with blue. I say, okay, alpha squared minus alpha plus 3 equal to 0. Beta squared minus beta plus 3 is 0. Why? Because we have this function and alpha, beta are roots. Now I want to prove this part, why it is correct. I multiply this by 1. I want to reach S3. S3 is what? Alpha cubed plus beta cubed. Can you guess we should multiply it by what to reach alpha cubed? Exactly, alpha. So I have alpha cubed minus alpha squared plus 3 alpha equals 0. And this one times beta cubed minus beta squared plus 3 beta equal to 0. Now if I add these two things, then I have alpha cubed plus beta cubed minus alpha squared plus beta squared plus 3 alpha plus beta equal to 0. This is what? S3 by the definition minus S2 plus 3S1 equals 0. It is exactly here. So you can do exactly the next one. For next one, you should multiply this by what? Alpha squared, yes, beta squared, and reach this. And we can prove all this things, and this is so much useful, Newton's sum. So here I've written this. So for ax squared plus bx squared, here I proved what? I proved sk minus 1 plus 3k sk minus 2 equal to 0 for k greater than equal to. So for this one, exactly by same proof, ax squared, you can say ask plus bsk minus 1 plus csk minus 2 equal to 0 for k greater than equal to. So this is so much useful, and we want to solve this in the video. If you had any question, feel free to send message to my WhatsApp number in the description and comments. Or also you can comment and ask your problems. Okay, so let's solve the problem. Okay, the problem is x plus y equal to x4 plus y4 equal 1, 2, 3, 4, and xy is what? So I call this one S, I call this one product of this, I want P. So the equation I can make from first part of my video, you can use my time codes, quadratic formula. X and y are roots of this equation minus sx plus p equal to 0. So x squared s is what? Negative 2x plus p is what? We want to find p is 0. So here S0 is what? S0 is x0 plus y0. Here our roots are. So let me, because we have x here, it's good to change it, for example, to w. Because it's a quadratic function. We x and y are roots. So let's change it to this one. And okay, so, yes, here it's okay. This one, x0, y0, there are roots. It will be 2. S1 is x plus y is negative b over a. B is what is this you can use, or you can use from assumption. It will be 2. Both of them reach 2. Now I want to find S2, which is x squared plus y squared. Then I want to find S3, x cubed plus y cubed. And then I want to find S4, x to the power of 4 plus y to the power of 4. Why I keep writing on the S4? Because I know S4 is what, and I find S4 in terms of P, so I can find P. So S2, we want to find S2. With Newton's sum that I said in previous part, you can use the time codes. It is what? Let me write rest with flag. S2 minus 2S1 plus P equal to, plus PS0 equal to 0. So S2 minus 2s1, which is minus 2 times 2, plus s0 is what? 2p equal to 0. If we have s2 here and take all things to right hand side, it will be negative 4, right hand side 4, plus 2p, change it to right hand side, negative 2p. So we found s2 is 4 minus 2p. Again, we use the same way for s3. Right here, S3 minus 2S2. We increase this. In previous part, I explained S3 minus 2S2 plus PS1 equal to 0. So S3 equal to 2S2 minus PS1. 2S2, S2 is what? 4 minus 2P minus PS1. S1 is what? Is 2. So it will be what? 8 minus 4p minus 2p. It will be 8 minus 6p. Okay, so let's write it here, and one thing is left, S4. Again, I write S4, I increase the indices by 1 minus 2S3 minus plus PS1 equal PS2 equal to 0. We should increase all indices by 1. So S4 equal to 2S3 minus PS2. 2S3 is what? If we replace S3 with 8 minus 6P minus PS2. S2 is what? 4 minus 2P. So here it is S4. If we expand 2 times 8, 16 minus 12P minus 4P plus 2P squared. And if I simplify, it will be 2p squared minus 16p plus 16. And we know S4 is what? 1, 2, 3, 4 from assumption of problem. So 2p squared minus 16p plus 16 equal to 1, 2, 3, 4. Now we divide both sides by 2. We want to find p. We divide both sides by 2. It will be what? P squared minus 16p minus 8p plus 8 equal to 6, 1, 7. And if we take 6, 1, 7 to left hand side, it will be 8 minus this. It will be negative 609 equal to 0. Now I want to factorize. It is what? It is 3 times 203. And you can say it is what times what? It is 7 times 2, 14, 63, 9. So if we consider 3 times 7, 21 times this, we can factorize like this. P minus 29, P plus 21. Negative 29 plus 21, negative 8. Negative 29 times 21 is exactly this part. So P can only be 29 or negative 21. Now we should check. If we check our equation, w squared, the roots are x and y. Our equation is this quadratic equation we've created, that x and y are the roots. If we paste it here, the discriminant, because it says x and y, the roots of this equation are real numbers. So the discriminant should be greater than equal 0. Discriminant was what? In first part I've explained. The thing inside the roots, b squared minus 4ac, it should be greater than equal 0, because if it is negative, x and y are complex numbers and x and y are real numbers from the assumption of the problem. B squared is what? 4 minus 4ac minus 4p should be greater than equal 0. It is equivalent if you divide both by 4, both sides. 1 minus p greater than equal 0. If we add plus p to both sides, 1 is greater than equal p. So p should be greater than equal 1. So p29 is not correct. P negative 21 is correct. And we know that x and y will be real numbers and satisfy all the assumptions. And we can also check the things were equivalent. So the answer of this problem is negative 21. Okay, so if you've learned something new, please subscribe and turn on notification, like the video, and thanks for watching my videos and support my channel. See you in my next videos.